Before we get into planning a cross-country flight, I want to make sure you are familiar with the VFR navigation log and how it works. There are many different iterations of this. Your flight school might have one they prefer to use, and that's okay. The purpose of the nav log is to plan your flight, execute your flight, and allow you to make adjustments as you go. As long as all of the goals are accomplished, it really doesn't matter what log you use. As you gain more experience and move along in your career or your recreational adventure, there are electronic options available as well. For your private pilot flight test, you will be required to plan and navigate using a paper nav log that was created using the E6B and traditional methods of flight planning. For the purpose of this course, we recommend using the Level Flight VFR nav log, as all of our instruction will be geared towards it. If in practice you decide to use a different one or your flight school's log, that's okay. Now let's get into it. The Level Flight nav log is broken up into three parts: flight planning nav log, performance calculations, and the active nav log. Each of these serves a different purpose, which I will explain as we talk about each one. Let's begin with the flight planning nav log. The flight planning nav log is the largest part of the nav log and the part you will be using for the bulk of your planning. I want to draw your attention to a few things that will help you use this nav log. Above each of the column headers, you will find the name of the tool or resource that you will need to make the calculation or find the information for that column. For example, we see here it says E6B. That means we need to use the E6B in order to get the value which goes into the box. The grayed out areas indicate that you can fill in these portions prior to the day of the flight. Doing this allows you to get some pre-planning done ahead of time so that you don't have to spend as much time planning this part of the flight on the day of. Instead, you can focus on evaluating the weather and performing all of your calculations. Map preparation, especially when you are new at this, can take some time, so always a good idea to get started early. This nav log is set up for one trip. What I mean by that is that one departure and one arrival airport. Each line of the log is used for a different leg of the trip. If you are flying direct from one airport to another, then you will only need one line. If you are flying from one airport to another by flying over a few landmarks along the way, and your course changes over each landmark, you can use separate lines on the log for each leg or segment of your flight. There are a few exceptions to this which we'll discuss later when it comes to climb legs and flying to your set heading point. So we're going to start with our route, our departure or from, and our destination to. The first line is typically our climb leg, so it would indicate the departure airport, and under the to box we would put TOC or top of climb. The reason we do this is because this leg is also the leg that takes us to our set heading point, where we will begin the main leg of the trip. Remember, the reason we have a set heading point is because you will generally not be flying directly from the departure airport to your destination. This can be due to air traffic control or area departure procedures. The set heading point will be one which you can visually navigate to in a short distance. The time, fuel, and distance will be pulled from your pilot operating handbook, but we'll talk about that later. If we have included a climb leg, the next leg will be from our set heading point to the destination airport. The altitude box is next. You can plan your altitude the day before your flight, but you may want to change it on the day of once you check the weather and determine a more suitable altitude. Maybe the headwind is stronger at the altitude you chose and you'd like to pick a different one. Remember the VFR cruising altitude order. Above 3,000 feet AGL, your altitude needs to be based on your magnetic track. Eastbound, you will fly at odd 1,000s plus 500. West, you will fly at even 1,000s plus 500. Now we can move to the true track box. This box is calculated using the line you've drawn on your chart and your protractor. We'll show you how to do this in another video. Now I'm going to skip ahead 2 boxes momentarily and talk about magnetic variation and track. Remember that the true track is basically up on the map, but that doesn't correspond to magnetic north. Why does this matter? Because our navigation equipment and heading indicator and compass references magnetic north. We figure out the difference between magnetic north and true north by referencing the chart. On the chart, we look for the lines of variation. It will indicate either east or west with a number of degrees. To calculate magnetic track for an east variation, we subtract from the true track. East is least and west is best. Now let's go back to the wind and outside air temperature boxes. We obtain this information from the upper winds chart, or the FDs. You need to know your altitude before you can fill out these boxes. Once we have our wind, we can calculate our wind correction angle using our E6B. Next, we move to the magnetic heading column. We obtain this by either adding or subtracting the wind correction angle to our magnetic track. This will be the heading you fly in flight. Now let's take a look at our speed boxes. Our true airspeed is found in our pilot operating handbook in the cruise performance charts or tables. Ground speed is calculated using the E6B at the same time that you calculate your wind correction angle. Calibrated airspeed is found using the E6B as well by converting true airspeed to calibrated airspeed. And finally, indicated airspeed is found using the pilot operating handbook conversion chart for calibrated airspeed to indicated airspeed. Next, let's move to the distance column. This can be filled out at the same time you are prepping your chart and drawing all of your lines. Time and fuel are both calculated using the E6B. Once we have all of the information we need, we can total up the distance, time, and fuel. You will notice that the fuel column has some extra totals we need to consider. Start, taxi, and run up. Your pilot operating handbook will give you guidance on how much fuel to allot for this. Fuel reserve. This is the fuel you shall, as regulated by the CARS, carry in excess of the fuel required for the trip. Contingency. This box is here for you to add even more extra fuel. The idea with the reserve fuel is that you never touch it. It's simply safety fuel. The contingency fuel is fuel that you foresee you may actually need. Examples might be flying out of busy airspace. You might expect some vectoring, which will result in you not taking the most direct route to your set heading point. Or maybe you anticipate some weather along your route, so you want to have some extra fuel in case you need to deviate around it. This fuel is really for whatever you feel you need it for. Many people recommend an extra 10 to 20%, but it's really up to you. Your flight school may also give guidance on their expectation of fuel contingency. That completes the flight planning navlog. Now we move into the performance calculations. This might be something you fill out partially ahead of time as well. We start with the RPM, gallons per hour, and true airspeed boxes. These are pulled from the pilot operating handbook for the altitude in which you intend to fly. Looking at the lower section, we see information for the airports we are using. In most cases, this would be our departure and arrival airports. Determine the altitude of the airport from the CFS. Next, determine the pressure and temperature by looking at the most recent METAR. To obtain the pressure altitude and density altitude, we can use our E6B. Referring back to the CFS, we need to determine the runway length. From this, we will complete the final 4 boxes as required using the charts and tables within our pilot operating handbook. Finally, we move to the active navigation log section. This section is used while in flight to keep track of the headings you will need to fly and the position checkpoints you have selected along your route. The gray sections will be completed the day before. Other boxes will be completed just prior to the flight. They will be transcribed from the flight planning navlog. The lower section will be used as we fly. The first line is the climb leg. The second, if required, is from level off to the set heading point. When we get to each checkpoint, we will complete the there check. We will discuss that in another video. Since performance for the climb leg is already accounted for, these boxes are blacked out. The time over the takeoff leg is the time off. The ETE box will be the time en route, as noted in the flight plan nav log, and the ETA will be the time off plus the ETE. If you are not already familiar, ETE stands for estimated time en route. ETA stands for estimated time of arrival. As we work along our flight, we will fill in the rest of the boxes. After passing over a checkpoint, we will write down our time. We then know how long it took to get there from the set heading point. Using this number, along with the distance, we can determine our ground speed using our E6B. After finding this, we use that number and the distance remaining to determine the estimated time en route for the remainder of the trip. We can then determine if our ETA needs to be updated. The final column is the revised magnetic heading column. Using the course correction methods you learned about earlier in the course, you may have found that you need to alter your magnetic heading in order to stay on course. This box is where we would record that heading. Now that we've discussed generally how this navlog works, let's plan a cross-country flight and put it into action.